Hi guys, welcome back to another video on RabbitMQ. In a previous video, we looked at the theory behind using various different exchange options and queue options, including alternate exchanges, dead letter exchanges, and accepting and rejecting messages. In this video, we're going to look at the C# implementation of those concepts. If you're more interested in a Python implementation, please take out the previous video, but this video will contain the exact same content and implementation except in C#. As usual, all the code can be found on my GitHub with the link in the description. So we're back again in Visual Studio Code, and you see I've created several folders here, and each folder has a consumer and a producer project in it. As usual, we've already installed the RabbitMQ client library, and we've just copied in our code from our very first C# example using RabbitMQ. So our connection code, queue declarations, and publishing is all there. So all the basics we have in there already. So let's start in the producer and the alternate exchange example. So we want to set up a consumer and a producer to use alternate exchanges. So the first thing we're going to do here is we're going to need to declare two exchanges. So instead of queue declare, we're going to use exchange declare. We're going to need to declare an alternative exchange. So we'll just call it alt exchange. And we want the type of this exchange to be the fanout type. So we'll say type and exchange type dot fanout. Instead of queue here, we'll just have exchange. So that's our alternative exchange declared first. Next, we'll declare what we'll call our main exchange. So this will be the exchange that when it receives a message that is un-routable, it will then send that message to this alternative exchange. So to do this, we'll just copy in our exchange declaration here. Instead of calling it the alt exchange, we'll just call it the main exchange. And it will be of type direct. And we want to declare this with arguments. So in the arguments, we need to say that this exchange has been declared and it has an alternate exchange. So in the arguments parameter, we're going to pass a new dictionary and of type string object. And inside that dictionary, we need to pass a key value pair that indicates that the alt exchange will be the alternate exchange for the main exchange. So to do that, we create a key in our dictionary called alternate -exchange, and the value will be the name of the alternate exchange, so just alt exchange here. That's declared two exchanges, the main exchange with an alternate exchange, which is pointed to this exchange that we've also created. We can leave the rest of the code more or less the same, except we obviously want to publish our message to the main exchange. We'll just give it the routing key of test for now, and we don't need to pass any parameters and just the body as usual. So let's jump into the consumer now, and let's make some changes to also support the use of alternate exchanges. So the first thing we'll do is just copy in our two exchange declarations as well. So now we're going to create two queues, one bound to the alt exchange and one bound to the main exchange. So to do that, we can use the queue.declare we have here. And the first queue we will just simply call alt exchange queue. And then we want to bind this alt exchange queue to the alt exchange. So we'll use channel queue bind, pass it the name of the alt exchange queue and also the name of the alt exchange itself. And we will just give this an empty routing key. And then we want to set up our consumer for the alt exchange. So we'll just call that the alt consumer, and when the alt consumer receives a message, we'll just write out the alt received a new message. And finally, we want to consume from this queue, so we'll consume from this queue, and the consumer will be the alt consumer we have created here. So now we've set up our consumer and our queue bind for our alternate exchange. We want to do the same for the main exchange as well. So let's copy all of this code here to create a new one. Instead of alt exchange queue, we'll call it the main exchange queue. And that's obviously going to be bound to the main exchange instead of the alt exchange. And we'll give this, in this case, the routing key test. And our consumer, we won't use the alt consumer, we'll create a new one called main consumer. And when that receives a message, instead of saying alt receive new message, we'll see main receive new message. And we want to consume off the main queue here. So that's everything set up in our consumer. As we've seen, we've declared two queues, the alt exchange and the main exchange, with the main exchange having an alternate exchange pointed to the alt exchange. Two queues have also been declared, one that's bound to the alt exchange and one that's bound to the main exchange. So let's fire up our code using terminal windows and see what we can do. So create a new terminal window. We'll cd into our alternate exchange and our consumer, and then we'll run that using .NET run. And now we are consuming. So we are consuming the main queue on the routing key test. So if we publish this message in here to the main exchange of the routing key test, we would expect that that message would be routable. So let's open up another window. Let's cd into our alternate exchange example and our producer. And like we said, this message should be routable, so we'd expect the main exchange to be able to handle it, and we would expect it to print out main received a new message. So let's send this using .NET run. And we actually pointed at the wrong consumer here. We have the alt consumer, so we'll change that to the main consumer. That's why we got this wrong message here. I believe alt received new message because it was actually pointing at the wrong consumer in our basic consume. So if we restart our consumer and publish the message again, we can see the main exchange has received that. And a second time, again, received by the main exchange, routed to the main exchange queue, and then to this basic consume here. However, if in our producer we publish on a different routing key, so this is not going to be routable anymore because the main exchange is not bound to the main exchange queue using the test2 key, and it should end up on our alt exchange because of this. So let's publish another message, and we can see indeed it has ended up on the alternate exchange. So that's it for the quick example on alternate exchanges. As usual, code will be on my GitHub. So let's next check out the use of the dead letter exchange. And to start this off, we're going to copy in the producer and the consumer code from our alt exchange example into the dead letter example. So that's our starting point. And the consumer here. Close our terminal windows. So let's start in the producer on our dead letter exchange. And what changes do we need to make here to set up the dead letter exchange instead of an alternate exchange? And remember that an alternate exchange is set up to listen to messages off another exchange that can't be routed, while a dead letter exchange is set up to listen to messages from a queue that can't be delivered to a consumer or expire or something like that. So in our producer, we no longer need to really declare a second alt exchange here or pass in the alt exchange arguments on our main exchange. And before we run this code, make sure to log into the RabbitMQ client running on your machine and just delete any exchanges and queues from any previous example you've done, as we might be using similarly named exchanges and queues here but with different settings. And as we know, once a queue or an exchange has been declared, its settings cannot be changed and will result in an error. Okay, so we've declared our main exchange, and we will say as our message, this message might expire. So what we're going to do in this example is we're going to publish messages onto RabbitMQ with an expiry in the queue. So once those messages expire, they will then be sent to the dead letter exchange. And we want to publish to the main exchange. We'll use the routing key test. And that's it from our producer. So quite simple from the producer point of view, just declaring an exchange and publishing a message. We need to make slightly more changes in our consumers. So let's first declare our dead letter exchange, and we'll just call it DLX for now. And that will be of type fanout. So very similar to the alternate exchange we created in the previous example, but we will bind it to the queue rather than the exchange we declare. So we no longer need to have these parameters with the main exchange. We can just declare a direct main exchange and the dead letter exchange as type fanout. However, now we need to declare our main exchange queue. So let's get rid of this alt exchange queue declaration for now. So on our main exchange queue, at the moment, we're just declaring it as the name main exchange queue. But what we want to do in this example is we want to pass some arguments into this to tell RabbitMQ that we are creating this queue with a dead letter exchange. So again, a new dictionary of type string object. And inside this, we want to pass two arguments. The first is the X dead letter exchange. And this tells the queue what is the dead letter exchange for this queue. And in our case, it's the DLX exchange. That's called DLX. And the second parameter will be the X message TTL. So this tells RabbitMQ that any message that is left on this queue over the TTL should automatically expire. So we'll set this to 1000, which says that any message that's been on this queue for more than 1 second will expire. And then we'll bind this main exchange queue to the main exchange, again using the routing key test. And then we'll create our main consumer the same as before, and we'll say main receive new message. But one thing we're going to leave out is the basic consume on the main exchange queue. So we're going to comment that out for now. And this is because we don't want the messages to be consumed off the main exchange queue right now. We want them to stay there for that 1 second and see, do they get routed to the dead letter exchange? So let's quickly just create a second queue to use with the dead letter exchange. So we'll just copy this code here down below. And instead of the main exchange queue, we'll just call it the DLX exchange queue. So this is the queue that will be connected to the DLX. So the one that we might use, say, for logging or alerting on messages that haven't been delivered. We don't need to pass any arguments to this, as the dead letter queue won't have its own dead letter exchange. And we will bind the dead letter exchange queue to the DLX, or the dead letter exchange, with the empty routing key. And then we'll create a DLX consumer. And when the DLX consumer receives a message, we'll just say DLX receive new message. And then we do want to consume off that, so we can copy this in below and create a consumer to consume off the DLX exchange queue and passing the DLX consumer there. So in the producer, it's been slightly more involved. Created two exchanges, the DLX and the main exchange. Then we created a queue with the argument that has a dead letter exchange pointed at the dead letter exchange we created earlier, and an TTL on all messages that go into the queue of 1 second. Then we've bound the main exchange to this queue, and we've set up a consumer, but we haven't actually called basic consume on that. So the messages will remain on that queue until they are expired by our X message TTL. Once they're expired, they will be sent to the DLX exchange based on the X dead letter exchange argument that we passed in the queue declare of the main exchange queue. And once they're received there, they will be passed to the dead letter exchange queue, which will consume them as normal and write out DLX receive new message. So let's open up some terminal windows and see how this works. Let's open up a terminal window and cd into our dead letter exchange example and our consumer. And let's start our consumer using .NET run. So that's consuming. We'll open up a second terminal window, cd into our dead letter exchange example and our producer, and run it using .NET run. And one thing we've done wrong here is we've passed the wrong expiry here. So what we need to do is just delete that S. It should be X message TTL with one S. So clearly spelling mistakes like this can have a big impact on our system. So if you make a mistake like that, don't forget you need to delete this queue and recreate it, as you can't change something like that once the queue has already been created. So once we've corrected that, let's restart our consumer using .NET run. And let's also start our producer using .NET run. And we can see here that we sent this message might expire. And in fact, as we expected, the dead letter exchange has received it, as the message has gone on to the main exchange, then passed to the main exchange queue. And because nothing is consuming off that, it's sat there for a second and then being sent to the dead letter exchange, which will route it to the dead letter exchange queue and log it out for us to see. And if you notice again, if we publish a message, it takes a little bit of time for the log to appear to say it's been received on the dead letter exchange. And this is because it's that 1 second where the message expires. Say if we up that to 5 seconds and restart at the consumer, we would see a little bit of a longer time. And also, if we restart the consumer, but actually start consuming off the main exchange queue, so let's try that, let's run it again, we will actually see that the messages won't be routed to the dead letter exchange because they are successfully processed by the consumer consuming off the main exchange queue. So let's publish another message with that change applied, where we are now consuming off the main exchange queue. And we can see that it is in fact the main queue that is receiving these messages. So that's it for our dead letter exchange example. Next, let's take a quick look at the accept, reject messages examples we have. So again, let's copy in our code for our consumer and our producer. So consumer and producer as a starting point for our accept and reject message examples. And what we're going to do in this case is we're going to do something slightly different. we're going to set up our producer to start sending messages when we press a button on our keypad. So let's do that in our producer here. We'll close our terminal windows first. And in our producer code, we will change the exchange name, say from main exchange to accept, reject, exchange. And we'll just make it a fan out exchange. And what we want is we want a loop to send messages every time we push a button. So we'll say while true. And inside our while true, we want to publish our message. So we'll copy all of that in here. So this message might expire. We don't need to say that anymore. We might say just let's send this. And we publish it not to the main exchange, to the accept reject exchange. And after we publish it, we can say send the message, but then we want to wait. So what we can do is we can say console.writeLine, press any key to continue. And then we can say console.rekey. So quite simple. Every time we press enter, another iteration of the loop will happen and we'll publish another message to the accept reject exchange. So we want to do the implementation on the consumer side next. So it's quite a bit simpler than what we had for the other examples. We only really need a single exchange here. So we don't need to declare two exchanges. We just need the accept reject exchange. We want to also declare a queue, but we don't need to declare it with any arguments. So as usual, we can just call this, say, the letterbox queue, our usual go-to queue. And we want to bind the letterbox queue to the accept reject exchange. And again, we can still have our main consumer here. So our main consumer and what we do when we receive a message on the main consumer. And then we want to consume off the accept reject exchange and point it at the main consumer. Our other DLX consumer and callbacks here, we can just delete. So inside our main consumer, when it receives a message, is where we want to add the code to accept and reject messages. And before we do this, we obviously want to turn off this auto acknowledge. So if we have auto acknowledge on, every message will be auto acknowledged as soon as RabbitMQ receives it. So even if our consumer hasn't successfully processed it, say successfully written it to the database or successfully done something like that, we will have already auto acknowledged it and the message will be gone from RabbitMQ. If we turn on manual acknowledgements, if for some reason we don't acknowledge the message, it will be requeued onto RabbitMQ and sent again to a different or the same consumer a second time. So let's delete that. And inside the main consumer received, let's do something different. So we want to manually acknowledge the receipt of the message. So we can do that by calling channel basic ack. And what we want to pass in here is the delivery tag. So like we said, the delivery tag is unique per channel per message. So the first delivery tag for a particular channel for a message received will be 0 and then 1 and then 2 and so on. So we can tell the broker exactly what message we want to acknowledge. So to pass that in, we say delivery tag, and then we want to say ea.delivery tag. And for now, we can say multiple false because we only want to acknowledge one message at a time. So let's run this example and just see where we're at. So we'll cd into our accept reject and our consumer and run that using .NET run. And this is saying there's no queue called accept reject exchange. So we're obviously consuming off the wrong queue. We want to consume off the letterbox queue, not the accept reject exchange. Let's make that change and try consume again. And we're consuming. So let's open our second terminal, cd into our accept reject exchanges and our producer. And let's publish a message. So just with .NET run. So that's sent a message. We can press any key to publish another message. And we can see as we press enter, we're sending more and more messages. If we look in the RabbitMQ portal, we can see that we have our letterbox queue here. And it has 0 unacked and 0 messages built up on the queue. If we go back to our consumer, and instead of acknowledging every message on receipt, we might want to acknowledge messages in batches. So let's say we want to acknowledge every 5th message. We might say if the delivery tag is a multiple of 5, so use the modulus operator. So every 5th delivery tag, we want to do something different. We want to acknowledge it, but we also want to acknowledge multiple. So on every fifth message, we want to acknowledge all the messages that came before it. So if we restart our consumer and say .NET run again, so it's running, and we send a message, we'll say we received it, we send another message. So now we publish 3 messages. Let's have a quick look in the UI here, and we can see that we're starting to build up these unacknowledged messages. So now we've got our 3 unacknowledged messages. If we publish another one, by pressing enter, we'll receive 4, and on the next message we receive, we would expect RabbitMQ to acknowledge them all. So we can see here we've got 4 unacked, 4 total there, it's waiting. But when we publish our 5th message and go back to our UI, we'll see that these messages will be cleared out now, as the consumer has now acknowledged them all. And we can do something very similar to reject multiple messages using the basic NAC method. So again, we want to pass it the delivery tag, and we want to say multiple because we only want to reject messages in batches of 5. But we can also use the requeue flag to say whether we want the message to be requeued onto the queue. So in the case where we say true, this means that when we reject these 5 messages, they'll all be pushed back onto the queue to be consumed again. So let's see what happens there. We restart our consumer. We'll publish 1, 2, 3, 4. So we've got 4 messages here. When we send the 5th message, we'd expect all these 5 messages to be sent back to the queue. But because this is the only consumer, they'll all just be delivered here to be rejected again. So we'll be stuck in sort of an infinite loop of consuming and then rejecting messages. So if we press enter, we can see that this has gone crazy now, and it's just printing out, let's send this over and over again. So we'll cancel these. And as we said, RabbitMQ will make the best effort to deliver to a different consumer if the message is rejected. But in our case, this is the only consumer, so this is why we end up in a situation like that. So to avoid that, we can pass requeue false. And if we run our consumer again and our producer, and we start sending messages 1, 2, 3, 4, and we publish our 5th message, we can see that we don't end up in that infinite loop. We can just keep sending, and it works very similar to the basic Ack. I hope you enjoyed the video where we touched on alternate exchanges, dead letter exchanges, and accepting and rejecting messages. If you did enjoy the video, please give it a like and subscribe to the channel for more RabbitMQ content.